Okay, so we are in this book right here, Foundations of Linear and Generalized Linear Models, Chapter 1, Question 3 of Chapter 1, or Question 1.3. And here's the question. I always feel bad with these types of questions where it's just you looking at the screen of me having written something. There's no code or anything, but I guess you can just read it and move on. So what do you think are the advantages and disadvantages of treating ordinal explanatory variable as either quantitative or qualitative? Okay, so what is an ordinal or an ordinal explanatory variable? Okay, so this is a variable that has that its values are categories, and those categories are somehow rank ordered, right? And so, for example, the example that I'm using here, and I think it's used in the book, is education level attained, right? So in some way, finish college is somehow greater than finish high school, right? There's more of something, more time, maybe more exposure to more concepts or whatever, but there's something about finish college that is somehow bigger than finish high school, right? And so in that way, it's kind of like quantitative data. However, it's not quantitative, or it's not quite quantitative, because so there's an interval. There's a difference between finish high school and finish college, okay? And then there might be another interval between finish college and finish graduate school, for example. And so we have two intervals, one between finish high school and finish college, and then another interval between finish college and finish graduate school, okay? But there's really no way that we can compare those intervals, right? How much, like, is the interval between finish high school and finish college bigger than finish college and finish graduate school, right? There's no sense in which the intervals compare, okay? Unlike numbers, right? So there's an interval between, say, 7 and 10, it's 3, and an interval between 10 and 13, right? So we have two intervals, one between 7 and 10 and one between 10 and 13, and we can compare those intervals, right? So that's why ordinal data is, even though it's ordered, it's not really numeric in the way that, well, it's not quantitative in the way that numbers are, okay? Now, it's also, ordinal data is also kind of like qualitative data, because our data is in categories, right? It's just that our categories in ordinal data are ordered in some way, whereas in qualitative data, it might be like colors, right? Or eye color maybe, so brown eyes, blue eyes, whatever. And in the eye color example, for instance, now in no way does it make sense to say that brown eyes are more than or less than blue eyes, right? The differences between them are not intervals. It's not directional at all. Okay, so we're asked, what are the advantages and disadvantages of treating this ordinal data as qualitative or quantitative or qualitative? Okay, so so one of the good things about this ability to treat it as qualitative or quantitative is that otherwise we wouldn't have a way of extracting the information that's contained in an ordinal variable, right? So by using it as quantitative or qualitative, we can at least put an ordinal variable into our analyses, and that's good because there's information in that ordinal variable that we want, and we want to be able to analyze and integrate into our analysis, okay? But this comes at a little bit of a cost. So if we treat it as, let's go with qualitative first, okay? So let's say that we're putting highest education level attained. So we have categories like finish college, finish high school, whatever. So even though the interval, like we were saying before, even though the interval between, say, finish high school and finish college it's not a numerical interval, there is some kind of information contained in that hierarchy there, right? It's just not really easy to define, to put your finger on, but there is some kind of information there. And so if we just treat the ordinal variable as categories without any rank order, then the information that is contained in that rank order is lost. Okay. Now, conversely, if we treat the ordinal variable as quantitative data, right? So maybe we say that finishes college or finishes high school is 1, finishes college is 2, finishes graduate school is 3. Now we're kind of starting to approximate the information contained in the rank ordering, but again, there is no meaningful interval or precise interval between 1 and 2 and 3 in this case, right? And so this could lead to mistaken conclusions. So for example, we might find that that finishes college leads to greater job income than finishes high school. Okay? Well, if we treat education as some kind of continuous numerical variable, we might be tempted to say, okay, well, 3 years of college is better than 1 year, even if the person doesn't graduate in either case, right? Because if education is good, and well, then some must be better than less, or more must be better than less, right? And now this statement may or may not be the case, but our analysis really can't address that question at all, right? And so we've made a mistake because we've interpolated between these values of finishes high school and finishes college, and figured that, okay, well, even if I don't get all the way to finishes college to the level of 2, well, maybe how about 1.5? Well, 1.5 must certainly be better than just high school, right? But we can't really back that type of a claim up, with this particular analysis. So anyway, that is it for this one.